Hey class, in today's lesson we're going to talk about using fundamental identities, which is found in section 5.1 part 1. In our objectives, or in this lesson, we'll recognize and write fundamental trigonometric identities and use fundamental trigonometric identities to evaluate, simplify, and rewrite trigonometric expressions. So we already know our reciprocal identities. Sine of u is 1 over cosecant of u. Cosine of u is 1 over secant of u. Tangent of u is 1 over cotangent of u. Cosecant u is 1 over sine u. Secant u is 1 over cosine u. And cotangent u is 1 over sine u. One thing that you'll notice in this chapter is that we're barely or very rarely referencing our angles as like theta. Because in this chapter we'll more so use it more in equations. So you'll either see like u or t or x, any of those variations to represent our angle. Quotient identities, we also know those as well. So tangent u is sine u over cosine u. Cotangent u is cosine u over sine u. We also know the Pythagorean identities as sine squared u plus cosine squared u equals 1, and 1 plus tangent squared u equals secant squared u. And then the last one, 1 plus cotangent squared u equals cosecant squared u. These are new, so some cofunction identities that you need to be aware of is that when you have sine of pi over 2 minus u, then that gives you cosine of u. Tangent of pi over 2 minus u is cotangent u. Secant of pi over 2 minus u is cosecant u. Cosine of pi over 2 minus u is sine u. Cotangent of pi over 2 minus u is tangent u. And cosecant of pi over 2 minus u is secant u. Also, something that's new is even and odd identities. So if you take the sine of a negative u, you'll get negative sine u. If you take the cosecant of a negative u, you get negative cosecant u. If you take tangent of negative u, you'll get negative tangent u. And if you take cotangent of negative u, you'll get negative cotangent u. I put those all in one column to better emphasize that if you have any of those trig functions of a negative angle, then they will become negative themselves. However, with secant and cosine, if you do those trig functions of a negative function, they don't change, so they will stay the same. All right, so in example 1, we're going to use the values of secant u being equal to negative 3 over 2 and the fact that tangent is greater than u to find the values of all 6 trigonometric functions. Okay, so if we know that secant of u is negative 3/2, what will be helpful for us to know also then is that secant is related to cosine u. Sorry, my pen is not working. Cosine u. And cosine is just the reciprocal of secant, right? Or secant is the reciprocal of sine or cosine. So instead of just negative 3/2, we will now have cosine u as negative 2/3. So in other words, it's asking, okay, well, if cosine is negative and tangent is positive, that's what this one is saying, tangent is positive, then what quadrant does that lie in? Well, let's think about it. Cosine represents our x values, and they're saying that your x is negative, so that's either the second or the third. Again, either the second or the third. And then the only place that tangent is positive is in the third quadrant, because in that quadrant, a negative divided by a negative y divided by a negative x will give you a positive tangent. Okay, so we're referring to quadrant 3. That's the main thing we need to know. Okay, so we can use, technically we could have used the triangles to figure this out, but the very top, the example number 1 says use identities to evaluate the function, so that's what we're going to do. So since we know that, and I should have done cosine a little differently, but I've already done it, but cosine u should actually be written as 1 over secant u, which gives us 1 over negative 3/2, which is how we got the negative 2/3. Okay, but I kind of just spoke through it. All right, another identity that we can use is that sine squared u plus cosine squared u equals 1. We have cosine, but we don't have sine, which is what we're trying to solve for. So I can, in trying to find sine, substitute in cosine, which is negative 2/3. It's supposed to be squared. That will give us sine squared u equal to, if you square both the numerator and the denominator of negative 2/3, you'll get 4/9. So sine squared u plus 4/9 equal to 1. If I subtract 4/9 on both sides, we will get sine squared u equal to 5/9. How did I get 5/9? Because 9/9 minus 4/9 is 5/9. Finally, we will take the square root for sine. And so sine u is equal to the square root of 5/3. So that's sine. And again, that's equal, not negative. All right, we also knew that cosine u is negative 2/3. We know that secant is negative 3/2. So we have 3 more to find. So sine, cosine, we know that tangent of u is just y over x. So that would be square root of 5/3 divided by cosine, which is negative 2/3. When you divide fractions, remember it's top divided by the bottom, but technically it's top multiplied by the reciprocal of the bottom. So this would be the square root of 5/3. That's a 5, sorry, times negative 3/2. So the 3's are canceled, and we're left with negative square root of 5/2 as our tangent. All right, from there, cosecant. Remember, cosecant of u, CSC of u is the reciprocal of sine. So that will give us 3 over the square root of 5. However, we can't leave a radical in the denominator, so if you multiply by square root of 5 over square root of 5, you'll get 3 square root of 5 over 5 as cosecant. Let's see, we already found secant, and then cotangent of u will just be the reciprocal of tangent, which would give you negative 2 over square root of 5. But again, we can't have a radical in the denominator, so that leaves you with negative 2 square root of 5 over 5. All right, and the last thing that we definitely want to check is to make sure that our quadrant answers are correct. Remember, in quadrant 3, you have a negative sine and a negative cosine. So my cosine here, we already knew was negative, which means that secant was also negative, which we saw at the beginning. It was told to us. And then it also means that sine and cosecant should be negative. So sine u should actually be negative square root of 5/3, and cosecant u should be negative 3 square root of 5/5. All right, let's look at example 2. In example 2, we are asked to simplify. So we have sine of x times cosine squared x minus sine x. As I mentioned, we're moving more into looking at these trig functions in terms of almost like variables, okay? So essentially, this is the same thing as looking at xy squared minus x, and I'm asking you to simplify. So essentially, both of them share a sine x in common, so I'm going to factor out using greatest common factor. I'm going to factor out sine x, so I'm left with sine x times cosine squared x minus 1. And we should know that, and let me rewrite that second statement because I don't want us to get confused. This is really negative 1 plus cosine squared x. If you remember, our Pythagorean identity is sine squared x plus cosine squared x equal to 1. Okay, if I wanted to get sine squared by itself, I would subtract cosine squared. And I'd be left with sine squared x equal to 1 minus cosine squared x. I'm almost to the point where I can substitute this for that, but I actually cannot because this is a positive 1 minus cosine squared x, and then what I have in my problem is a negative 1 plus cosine squared x. So in other words, I really just need to factor out another negative. So if I factor out a negative from here, I'll have negative sine x times 1 minus cosine squared x. In other words, I just divided it by negative 1, or factored out a negative 1. Okay, now this 1 minus cosine squared x is the exact same that we have over here, which means that it is the same thing as sine squared x. So this is negative sine x times sine squared x. And a negative sine x times sine squared x is going to give you negative sine cubed x. And that is your final answer for that expression. Sorry, this is really messy. Okay, and our last example, verifying a trigonometric identity. So we're going to verify this identity. So it says sine theta divided by 1 plus cosine theta plus cosine theta divided by sine theta. Okay, equals cosecant theta. And by the way, this program that I'm using, it really should just show CSC. For some reason, this program doesn't write cosecant the way I prefer, but anyways. So remember, when you verify, you're simply simplifying one side only. Okay, we're simplifying one side only. And the side that we're going to want to simplify is the left side to prove that the right side is cosecant theta. Okay, so all the work that I'm going to prove is about the left-hand side. So the first thing I see is that I see two fractions that have different denominators. So to make them have the same denominator, I'm going to multiply each fraction by the other's denominator. So I'm going to multiply this one by sine theta over sine theta. I'm going to multiply the other one by 1 plus cosine theta over 1 plus cosine theta. Okay, so for this fraction, if I multiply the tops, I'm going to get sine squared theta over, and let's just leave this as sine theta plus or times 1 plus cosine theta. And then on the other side, if I multiply this fraction, just the numerators, I'll have plus, and I should really distribute the cosine, right? I will have cosine theta plus cosine squared theta over, again, sine theta times 1 plus cosine theta. Okay, putting all those numerators together will give us sine squared theta plus cosine theta plus cosine squared theta over sine theta times 1 plus cosine theta. What you should recognize at this point, especially in the numerator, is that sine squared theta and cosine squared theta equal 1. So that'll give us 1 plus cosine theta over sine theta times 1 plus cosine theta. What then happens is that the 1 plus cosine theta of the numerator cancels with the 1 plus cosine theta of the denominator. And we're left with, I need to draw arrows, we're left with 1 over sine theta. And again, 1 over sine theta is cosecant theta, and we've proved our point. Cosecant theta equals cosecant theta. Again, with trying to prove trigonometric identities, your goal is to verify or simplify one side only so that it equals the other side. All right, guys, that is all. If you have any questions, please be sure to come see me for tutoring.